Okay, so we've seen how adding a number to the ends of the x interval of a basic function is equivalent to replacing x values by x minus 2. So that if you add h to every x value, that makes the function f of x into f of x minus h. And that's illustrated by the way the numbers come out here, the fact that this function gives you the right numbers for the relabeled graph. If you multiply all the y values by a number, in this case 3, that gives you the function 3 times the original function. Okay, this is a reciprocal square graph. Y equals 1 over x squared. Here are the values. If I multiply all the y values by 3, then we'd better multiply the expression for the y values by 3. And then, in general, when you multiply the y values by a, that changes any function f of x to a times f of x. Okay, now we want to see what happens in another kind of transformation here, where the y interval keeps its same length. Length of the interval is from 0 to 4, length of the interval from 2 to 6. Both of these intervals have length 4. But the numbers are going to change. So the y numbers are going to become 2 here and 6 here. Now halfway between 2 and 6, of course, is 4. Halfway between 2 and 4 is 3. Halfway between 4 and 6 is 5. So here's our new y-axis. Now the problem with our y-axis here is we've got to get down to the origin, even though it's not part of the relabeled domain. We want the y-axis to go as far as the origin. And the origin is going to be somewhere below 2. How far below 2? Well, units are this big, so we come here, and we've got 1. We come here, and we've got 0. Now here's our new y-axis. Here's our new y equals 0, and that's going to tell us where the new x-axis goes. So here's our new x-axis. Here's our new y-axis. We should label these over here. Here's x, here's y. Labeled y, but here's x. Okay, so this means that the function is higher than it was before. The x values now for the original function, basic exponential y equals 2 to the x. Remember our values for 1/4, 1/2, 0, 2, and 4. On the new function that we get for the relabeled axes, x values haven't changed. They're still -2, -1, 0, 1, and 2. But now what are the y values? Well, the original function had a y coordinate of 1/4 here. So that's 1/4 of a unit. But now you got to go up 2 just to get here, and then another 1/4. So this would be -2 1/4. I'll write the mixed number, although generally we want to use improper fractions, -9/4. But here's our new y value. Y value for our relabeled function. At -1, we're going to get -2 1/4, it's 2 1/4. We're going to get 2 1/2. At 0, well, how far do we have to go from here to here? Got to go 2 units to here, another unit to here. Well, clearly the coordinate of this point is 3. Okay? So again, coordinate of this point is 2, and there's a quarter. Coordinate of this point is 2, and there's a half. Coordinate of this point is 3. according to the point corresponding to x equals 1 is 4. And according to the point corresponding to x equals 2 is 6. So, what's the formula for this function? Well, all we have to do is add the 2 that we've got to go to get from here to here, from the value that the function had relative to this axis, and we get it. So y equals 2 to the x plus 2. And of course now, if you plug these numbers into this expression, you are going to get these numbers, and here's geometrically how that works out.